In this example, we are going to talk about graphing a line or graphing a linear function. And this time, instead of using a table, we are going to use the slope and the y-intercept. So this time, we are going to be using a little bit of a shortcut. Okay, please know that you can always graph using a table. You can graph any type of function using a table. But today, we're going to show a shorter method. So first of all, I want you to see here, again, you can definitely graph using a table, but I want you to note the form in which this equation is written. This form is called slope-intercept form, and it is y equals mx plus b, where m is the slope and b is the y-intercept. So anytime you see an equation that you can basically write y equals mx plus b over the top of it, you can use this shortcut method, okay? So slope. Slope's your average rate of change. When we're talking about a linear function, it's going to be constant. And here's something super important. It's rise over run. It's the change in your y over the change in your x. So we can simplify that by saying it's our rise over our run. Okay? Now the slope has already been found for you right here. In this equation, our slope is 2/3. So we know that our rise is 2 and our run is 3. And I'm going to show you what that means on a picture. So again, we know that our slope is rise over run, and now we have our y-intercept, which is where the line is going to cross the y-axis. Remember that in a coordinate grid, the y-axis is your up and down axis, your vertical axis, okay? So you need to have this written down somewhere. Y equals mx plus b, okay? Where m is your slope and b is your y-intercept. Okay, super important because those are the two pieces that we are going to need to pick out of the equation in order to graph it. So let's start. Here's your process, which you should have written down somewhere. Pause the video if you need to. But we're going to start by identifying the y-intercept and the slope. So in our first example, we're going to write above this equation or below it, y equals mx plus b. Remember that slope is m. So which one of these values is your slope? The 2/3. So 2/3 is our slope. And which one of these values is the y-intercept? Well, b is the y-intercept, which means the +1 is going to be our y-intercept. Let's take a look at our process again. We have identified the slope and the y-intercept, so next we want to plot the y-intercept on the y-axis. So our y-intercept is 1. If this is a y-intercept, am I going to go up 1 or right 1? I'm going to go up 1. So we're going to make a dot right there where our y-intercept is 1. Let's go check our process again. We've done that. Now we're going to count off the slope and make a point and repeat and repeat and repeat and repeat. So remember that slope is rise over run. This slope is positive, so we're going to be rising, and we always run to the right. So from our y-intercept, we are going to go up 2 and over 3. So this is our next point. You should not actually have these dots in here. I'm just trying to help you see where I'm counting. Okay? So we're going to do it again. We're going to go up 2 over 1, 2, 3. Here's our point. We go up 2 over 1, 2, 3. There's our point. And then I can do it again going backwards. If we start back at our y-intercept, I can go backwards now. Instead of going up 2, I can go down 2. Instead of going right 3, I can go left 3. So there's our other point. And do it again. And this same pattern just repeats as many times as you can fit it on the graph. Okay? So we've got all of our points. Check. Now we're going to draw the line using a ruler. Okay? So if you don't have a ruler, grab your ID card, grab the edge of a notebook, any type of straight edge that you can use to help you draw your nice straight line. And then, what do we always need at the end of any line? We need arrows. Okay? And remember, all these little dots in between are not actually part of our linear function. Okay, that was just me trying to help you see where we can count. So all you should have are your points along the line, and then your line. And our line is a little off here. There we go. Okay, so there's our linear function. Let's try another one. So again, the first thing we have to do is identify the slope and the y-intercept. What is the equation we want to use to help us identify that? It's slope-intercept form, y equals mx plus b. Which variable, m or b, stands for the slope? M. So what is our slope? It's 3. And what is our y-intercept? It's -1. So from the origin, we're going to go left 1 or down 1? Down 1. After that, we want to count our slope. Think about this. How do we turn 3 into a fraction? We can put it over 1. So that now if I'm thinking rise over run, am I going to go up 3 or right 3? We're going to go up 3. So 1, 2, 3, and over 1. 1, 2, 3, run 1. 1, 2, 3, run 1. Awesome. I can't fit any more, so I'm going to go back to my y-intercept and we're going to go backwards. So from my y-intercept, I'm going to go down 3 and left 1. Down 3 and left 1. If you ever get a picture that does not make a straight line for a linear function, then you did something wrong. It should always, always, always make a straight line. That's what a linear function means. Yeah. Go this way. Here we go. And what do we always need on the end? Arrows. Why do we put the arrows on the end? Because it means this line goes on forever in both directions. Awesome. Let's look at example 3. This one throws a lot of people off because we've got this negative here. Okay? Anytime you have a negative in front of the fraction, you want to make sure only one piece of the fraction is negative. Okay? If you made it both a -1 and a -4, that would make the whole fraction positive, and we can obviously see this fraction is negative. So when graphing, I like to associate the negative with the numerator, which is the top number. So in this case, that would be the 1. All right? So now, when we write our y equals mx plus b, what is my slope? It's a -1 over 4. And what's my y-intercept? It's 5. So where am I going to start? Do I go up 5? Do I go right 5? Do I go down 5? Do I go left 5? I'm going to go up 5. It's a y-intercept, remember? So we've got to be at the y-axis. Then from there, this time my slope is negative. So I'm going to go down 1, but I'm still going to go to the right 4. Okay, down 1, right 1, 2, 3, 4. Then when I go backwards, I can go up 1 and go back 1, 2, 3, 4. Up 1, back 1, 2, 3, 4. Those are as many dots as I can fit. So we're going to draw our line. It's a little off. Let me fix it. Here we go. And again, what do we always put on the ends? Arrows. So there's my linear function. Let's try another one. This time, I'm going to write my y equals mx plus b. And what is my slope? It's a -2. What's my y-intercept? 5. How do I turn this -2 into a fraction? We put it over 1. So, where am I going to start? We're going to start up 5. 1, 2, 3, 4, 5. Where am I going to go from that 5? Down 2, over 1. And we keep going. down 2 over 1. Over and over and over. And then we go backwards. What do I mean by going backwards? Where are we going to go? Going to go up 2, back 1. Up 2, back 1. So we've got all of our points. Let's draw our line and put our arrows on the end. And we have our linear function. Try this one on your own. This one's a little tricky. What's our y-intercept? What could I add at the end that wouldn't change anything? A 0. So what's my slope? 3 over 2. And what's my y-intercept? 0. So we're going to start right there at the origin, and then we go up 1, 2, 3, and over 1, 2. Up 1, 2, 3, and over 1, 2. Up 1, 2, 3, over 1, 2. And then we can go backwards. So go down 1, 2, 3, and back 1, 2. Down 1, 2, 3, back 1, 2. Down 1, 2, 3, back 1, 2. And then we draw our line and put our arrows on the end. Beautiful. I believe you have one more graph on your notes, so let's try this one. Y equals 2/3 x plus 2. So what is our y-intercept? Our y-intercept is 2. What's our slope? 2/3. So where am I going to start? 2. So from there we go up 2 and over 1, 2, 3, up 2, over 1, 2, 3, up 2, over 1, 2, 3, and then we go backwards. Down 1, 2, 1, 2, 3, down 1, 2, 1, 2, 3, down 1, 2, 1, 2, 3, and I'm out of room. So we can draw our line and put our arrows on the end. And then, of course, I just want to remind you one more time that these extra dots are not part of our function. They were just used so you could see where I was counting. Great job. Try some of your practice problems.